Hi everyone, it's me, Carolyn, and today I'm going to be talking a little bit about Chapter 1, Section 1, which basically starts talking about data and just some of the terminology that we have that goes along with it. I do have the guided notes in front of me, so I will be using them. I did provide them for you on our Blackboard site, so feel free to follow along with those or use them as a place to make your own notes. I hope this helps in you understanding what you have read in this first section. I'm going to share my screen so that you can see the notes. There they are. And again, it's basically just about terminology. I did have my pen. Oh, here it is. But I'm going to add in some extra pieces as I'm walking through this. I will kind of read through it, but I'm also going to add extra examples or extra verbiage to help clarify some of the things that we have. So again, first of all, the terminology, we are in a statistics course. So it might be nice to know what in the world statistics is. It is a science, just like biology and mathematics, they are a science. And what we do in statistics is we conduct studies to collect, organize, summarize, analyze, and draw conclusions from data. Now, not all of these things are done all of the time. This probably shouldn't have been the word and, it probably should have been the word or, because sometimes statistics is just collecting the data and then organizing it a little bit. So we sometimes don't go all the way to draw conclusions. Okay, so there are many facets of statistics, and we're in this course, we're only going to hit on a few of them. We're going to see all of these pieces, but we're not going to see all of statistics. That would take us years, to be honest. All right, a variable, that is a characteristic or an attribute that assumes different values. So it's kind of like what we're trying to study in the situation that we're looking at, whether it be a person's height, their hair color, their how many ounces are in a can, how long a light bulb is going to last, how long a battery will last, how fast a specific plant grows. All of those things are characteristics that we might want to study, and we like to use variables to study them. The data is going to be the actual outcomes of those variables. So for example, hair color, the different outcomes we have blondes, brunettes, we have black hair, we have white hair, we have all the other variations in the middle. If we were looking at true hair color versus dyed hair colors, all of those different colors would be those data values that we take on. Random variables are a little different in the fact that it is something that's determined by chance or something that we can't really control. So for example, our hair color, if it's dyed, we can control that. But how high we grow or how tall we grow, how tall we grow is something that isn't really determined by something I do. It is kind of determined by chance based on my parents and my parents' parents and so on and so forth. So a lot of times random variables are something that we would study. And our data set is if we go and measure a bunch of different people and we get a whole set of data from these people. So that would be like a data set. So a bunch or a collection of those values. Okay. The first thing that we kind of want to kind of clarify is the difference between a population and a sample. And when we're working with some of our summarizing of our data, it will be important as far as what are we looking at? Do we have the population or are we looking at a sample? The population, or that term population used in statistics, we are talking about the entire group of subjects, whether they be people or things that we're looking at. So if we're talking about hair color, we'd be looking at women, we'd be looking at all the women in the United States. Or if we wanted to think worldwide, we could go the women of the world. A sample is just going to be a collection of those people. So a small group or a select group, the ones that we can actually possibly look at. So a sample is a subset of the population, a smaller set of the population. And most of the time when we do statistics, we do not have the entire population. We only have a sample that we're working with. And hence the reason a lot of times we need to analyze it and then we make predictions based on what we saw in that sample. Okay. There are two different types of statistics. And one is called descriptive and the other is inferential. A descriptive statistic just describes the situation. They just tell you what they find. 5 out of 10 of these people liked pepperoni on their pizza. They didn't do anything about it. They just stated the facts. They may have described it in a picture. Here is the breakdown of maybe the pie chart of the Democrats to Republicans to independents. So they didn't really say anything about make any conclusions or anything. They just, here's the information. That's a descriptive statistic. And inferential statistics goes a little bit further and states some sort of conclusion. 3 out of 5 dentists prefer this Crest toothpaste versus others. So you should use Crest because it's better. So that extra little step of making predictions or making some sort of conclusion based on something, that's the inferential. And in here, we will do a little bit of both. We will do some descriptive and we will do some inferential. Some other examples of descriptive is if we just find an average. So the average height of women is 53 inches. I don't know if that's true or not, but that would just be a descriptive. If we try to infer that onto the entire population, then that's when we start getting the difference of the two. Okay, we talk about qualitative versus quantitative data. Okay, a qualitative data is now, again, we're looking at the outcomes that these values take on, or the values that our data takes on. So when we talk about qualitative, it's more of a descriptive, non-numerical piece. However, it can be numbers, so non-numerical meaning that those numbers really don't take any value. So some examples of qualitative, well, hair color. That is a qualitative. Your gender, being male or female, your political views, Democrat, Republican, independent, any of the others that are out there. Those are all like a qualitative measure. Some other numerical qualitative ones is sometimes a zip code, or your, the word I'm looking for, area code. Even though those are numerical in nature, they're not really considered quantitative numerical. It's more of a qualitative, just describes. So a zip code describes where you're living using numbers. Area code describes on where your phone is located using numbers. So again, it's more of a descriptive, not a numerical value. So like I live in Minnesota and my area code or my zip code is 55943. That kind of just puts me in the southeastern part of Minnesota. It doesn't really tell people that I have that quantity. Okay, quantitative is a true numerical value. So like our weight, our height, our age, those are all numerical measurements. So if I want to think about it, measurements is a good word to put in here. So some sort of numerical measurement. Okay, when it comes to quantitative measures, so we have these numerical measures, and this is again looking at what possible outcomes did we get, not actually the one single value that you did get, but our possibilities, we can look at discrete data or continuous data. The way I kind of like to think about it is looking at a number line. So if we look at a number line, a discrete value is going to take on just dots along that number line. Now they could go on and on and on and on forever if you wanted to. So let's say some examples, the number of siblings you may have. The number of credits you're taking, the number of loaves of bread made in a day or slices of bread. Okay. We have 1, 2, 3, 4, 5, 7, 12 siblings. We aren't going to have 1.5. We aren't going to have a fractional piece. Now, discrete does mean we could possibly have fractional values, but again, they're just spaced apart. They're just like if you're looking at a number line and you listed all the possible outcomes, you would put dots on this number line. A continuous data is something that's going to take on that take on everything in that value. So for example, a person's weight could be anywhere theoretically from 0 and up to, I don't even know, 1,000 pounds, 10,000 pounds, but any value in there is a possibility. So weight and height and time, weight, height, time. So all of those sorts of things are continuous measurements. Volume, because you could have, filling up a cup could be on just about a continual thing. Think about it as like, it got this piece going on. It's continuously going. You're not going to jump from here to here without going through all the values in between. Sometimes there are data that we can look at. It may be a continuous kind of understanding, but we can look at it in a discrete format. So for example, our age, and if you want to think about it, you are 18, 19, 20 years old, maybe older, younger. That would be looking at it in that terms. That's a discrete situation. However, if you start breaking it down to how old are you, well, you're 19 years, 33 months, 15 days, 8 hours, 16 seconds, 0.53, whatever. So we could look at it and that continual spectrum because you're continuously aging. We don't jump from being 5 years to 6 years without going through all the middle. So there are situations where we can look at both. So age is one of those that can fall into both categories. We like to think of age, though, on a continuous. Sometimes we do look at it as discrete. I do want to warn you that even though these things are continuous variables, we measure them with discrete measuring tools. So like when you step on the scale, it tells you that you are 115 pounds. And that's just because that's what the scale is set to do. It tells you to the nearest pound. However, you don't weigh 115 pounds exactly. You weigh somewhere between whatever it had to round to show you that value. So these are continuous variables, but the measuring tool sometimes is a discrete piece. Okay, one last topic in this section, and that is the level of a measurement of a variable, and it kind of builds. Okay, so it's kind of looking at these variables and looking at how we measure them. The nominal level is if a variable is just kind of like a name, label, characteristic. It can't be ranked in a specific order, has no, like hair color. I have brown hair. It can't really be ranked in an order. Okay, so that would be considered something that is, in that first level or that nominal level of measurement that we have. From there, we can step up a little bit. So going to kind of put this couple examples in here for us. Our hair color. Another one is gender. That's another one. Again, you can put that label on there, but we really can't rank them in a specific order. Okay. Next one is stepping up a little bit. Now these kind of build. So if you think of all the ways we can measure, an ordinal is something, again, it's going to be a nominal level. So it's kind of some sort of rank, some sort of labeling, but it takes on this extra characteristic that we can label them. Order them, sorry. Order them. So for example, our zip codes. We all have a zip code. It kind of labels us. It really isn't, doesn't have any value to it or anything like that, but I could order them in numerical order. Your name. Everybody has a name. It is a way of labeling you, and we could put it in alphabetical order. We do that all of the time. The grade you earn in a class. I'm thinking of your A, B, C, etc. is a way of labeling. And we can order them if you want to from what we think of as the highest to the lowest. Okay, so that's kind of looking at data or measuring data in an ordinal level. We can step up a little bit more and we can talk about the interval level. An interval level, again, has an ordinal level, so we've kind of been building. So we have this label that we have. It can be arranged in a specific order. And furthermore, we can take the difference meaning subtraction, and that subtraction has some sort of meaning. So, I have the zip code. Okay, I could subtract 2 zip codes, but the answer I get has no value whatsoever. Another thing to kind of keep in mind in this one and our last one is the number 0. So if I subtracted and I got a 0, that doesn't mean I don't have that quantity anymore. An example of this is temperature. Giving you an example here. Because we can take 2 temperatures and we could subtract them. And when we get that 15-degree difference, we understand that 15 degrees difference of temperature. A 15-degree or 15 difference in our zip codes means nothing to us, but a 15-degree difference in our temperatures does mean something. Also, 0, having a temperature of 0 doesn't mean we don't have a temperature. That's just what the temperature is. Okay, so we can add temperatures, we can subtract temperatures. So I can add 15 degrees. I understand what adding 15 degrees does. It gets hotter. Subtracting 15 degrees, it gets colder. So that's kind of that interval level. And the last one is our ratio level. And here again, building, we can have a label that we can put in order. We can now subtract them, but even further, we can multiply and divide them, and it makes sense. So some things to think about here is, and again, the 0 is the absence of that quantity. So thinking about your numerical grade. Scored on a test. If you got a 0, it means you didn't do it for the most part. Or you had no understanding of that value. The number of days that a student misses. This class. Okay, again, the 0 means you haven't missed any. So it's the absence of that quantity. Okay, so here in this first section, we just kind of talked about data, the different types of data, qualitative, quantitative. Quantitative, we have discrete and continuous. Some of them have a little overlap, and then how we can measure things and how it builds. I don't spend a lot of time on this measurements, levels of measurement, because it is kind of confusing. But we do touch on it just a little bit, just to get our feet wet and so forth. In the next few sections, we're going to be looking at not so much this data itself, but how we get data. Some of the things that go into collecting that data. So this was our very first section. Hopefully, going through these notes and reading the material and watching this video, you have a better understanding. If not, make sure you kind of email me your questions, and we can talk. Look for you in the next video.